There's more to light than meets the eye, literally. Madam Toastmaster, fellow members and guests, this concept of light infiltrates our culture. We even use it in our metaphors that cover a spectrum of topics, such as, I see the light at the end of the tunnel, or you are the light of my life. But what is it? Many of us know that nothing travels faster than the speed of light in a vacuum, 300,000 kilometers per second. Or that the basic unit of light is a photon, but that light exhibits properties of both particles and waves. There's much to be said about light. In fact, there's an entire branch of physics devoted to the study of light called optics. First, I will discuss the electromagnetic spectrum, that is visible and non-visible light. Then I will further discuss visible light and colors and what we see when we see. And finally, I'll give an example of how this information is used. The electromagnetic spectrum is a continuum of the different types of electromagnetic radiation, categorized based on wavelength. Wavelength, as we see over here, is the distance from peak to peak of the wave. And so the wavelength of A, from here to here, is longer than the wavelength of B, from here to here. There are 7 main types of electromagnetic radiation. Radio waves have the longest wavelength, followed by microwaves, then infrared light, then visible light, followed by ultraviolet light, X-rays, and then finally gamma rays with the shortest wavelength. Many of us have an idea of what the various types of electromagnetic radiation can be used for, but let's give some examples for your edification. Radio waves are used in cell phones to transmit and receive signals. Microwaves are used in microwave ovens to heat our food. Infrared light is used in a television remote control to send the signal to the TV. Ultraviolet radiation in moderation can produce a suntan, and it induces the production of vitamin D in the skin, but in excess can cause sunburn or even skin cancer. While humans do not see this, some insects such as bees can actually see ultraviolet light. X-rays can penetrate soft tissue but not bones and are used in medical imaging. And finally, gamma rays with the shortest wavelength and the highest amount of energy can be used in some cancer treatments. As is apparent by these noted uses, the discovery of these different types of non-visible light has proved quite beneficial for us. But what can be said of visible light? As I stand here, I presume most of you can see me, but what exactly are you seeing? We're not directly connected, so how is it that you're conscious of this image of me? Of course, we have light to thank for that. The piece of the electromagnetic spectrum that comprises visible light makes up less than 1/1000% of the entire electromagnetic spectrum. In this room, there is some photon-producing light source, such as the light coming in through the blinds from the sun or from the ceiling light. Objects in this room, such as myself, are reflecting the photons back to your eyes, which in turn are absorbing them. Objects can absorb some frequencies or wavelengths of light, and the ones that are not absorbed are reflected, giving us the colors that we see. For example, green plants contain chlorophyll, and chlorophyll absorbs the blue and red frequencies of light and reflects back the green. A banana absorbs the blue part of the spectrum and reflects the red and green parts, producing yellow. Another manner in which we see color is if the object itself is emitting light at a specific frequency. The sun gives off what we call white light, but white light, while colorless, is actually a mixture, or shall we say a shindig, of all the different types of color that are present. This is evident if you view the white light through a glass prism, and you'll see that it separates the white light into the various colors of the rainbow. Now that we know some facts about light and color, what can this be used for? A few examples have already been mentioned across the electromagnetic spectrum, but there are manifold other uses of light. An interesting example has to do with night vision goggles. The hotter an object is, the more energy it releases and at a shorter wavelength. Humans give off heat, but it's usually emitted at wavelengths longer than that of visible light. Night vision goggles enhance radiation outside the range of visible light, such as infrared light, so that objects emitting light at those wavelengths can be detected. Light wears many hats. It is used for new technologies such as cell phones and TV remotes, and it aids in some cancer treatments, and it can even be used to determine the chemical composition of substances from Earth to the most distant galaxies. Light might have one final lesson to reveal to us. Michael Strasfeld, who is an American rabbi, said the following about light. Light gives of itself freely, filling all available space. It does not seek anything in return, and it asks not whether you are friend or foe. It gives of itself, and is not thereby diminished.